In this session, we are going to learn about multi-threading in Python. So Python allows to have different parts of a program run concurrently, and this design is called multi-threading. That is, each thread is a sequence of instruction in a program, and that can be executed independently. Right, so we can see this in detail today, and we'll have a program having multiple sections or multiple methods, and we will try to execute these methods concurrently. Right, so let's go ahead and create a program. And in order to use threading into our application, we have to import a module called threading. Comes along with Python. We don't have to install it separately. Let's import threading, and let's create a function f1. So I have a function here f1, and what it does is I'm going to, let's say, print the loop three times and print f1. Okay, and let's have a different f2, and this will also run a loop range of 3, run a loop for 3 times, and then I'm going to print f2. Okay, now these functions we can run independently, right? So I can just give f1, and then if I run this program, it will run this f1 function, once, and it will loop 3 times. It's going to print f1, which is inside the function. And I can do f2 also. So what will happen? First F1 will run, and then F2 will run, and then our program ends. I just print here program completed. This is the single thread application, meaning whatever we are doing, it's happening in a sequence, right? So there is an order here: first F1, then F2, and then it prints program completed. Now, what if you want to run both F1 and F2 simultaneously? Okay, that is, let's say I give a delay. Let me import from time import sleep. I'm giving a delay in each loop. Let's say I'm giving a delay here for 1 second. Here I'm giving a delay of 2 seconds. Okay. So now what happens is F1 program has a delay of 1 second in every loop, right? So now it will take longer to complete. That means if I run this, F1 is printing while F1 is doing its job, F2 is waiting. Okay, so F2 will not start until F1 is completed. So if there is a scenario where we don't want F2 to wait for F1 to complete, and we want it to run simultaneously. Okay, so to achieve this goal, we'll have to use the concept of threading. So let's do one thing. Let's create a thread. So we can create two threads, and each thread we can make these functions run. Okay, so for that, let's create a thread T1, and T1 we call as threading.thread. This is how we call a function within the thread. Okay, so I give threading.thread, and then I give target equals, and I have to give the function name. Function name is f1, and then I create another thread t2, threading.thread target equals f2. Instead of calling like this f1 f2, I have to call the thread. So I give t1 dot start, Okay, and then T2 dot start. So remember, the program itself runs in a main thread. Okay, so there is a main thread. In addition to the main thread, I have created two more threads, T1 and T2. Okay, main thread will execute straight away and then it will print program completed. Okay, and then thread 1 will run, thread 2 will run. So now if I run this program, all the three threads will run, right? So let me run this. So in the F1 function, I have given a delay of 1 second. F2 function, there is a delay of 2 seconds, after every loop, so that we know the difference. I have given that. Then I'm starting T1, starting T2, and that's it. So now let me run this program. So if you see that program, F1 printed, F2 printed, and program completed also printed. And then F1 is printing, again F1, then F2 and F2. So here you can see that F2 is not waiting for F1 to complete. As soon as I ran the program, all the three threads started. F1 started, that means thread 1, which is called function 1, has started. Thread 2 also started, it is called F2, and then main thread also started. Got it? And after that, since this loop has a 1 second delay, then after 1 second, it will again print F1. So it is printed F1, and again after 1 second, it's printed F1. And by that time, F2 2 seconds are over. So F2 is printing, and F1 already completed, right? So it's printing F2 and F2. So this is what multi-threading is. All the three threads happening simultaneously. Okay. Well, let's say I don't want all the threads to run simultaneously. What I want to do is I want to run the thread 1 first and thread 2 and the main thread should wait. Okay, for thread 1 to complete. So for that, I give an additional function called join. If I give t1 dot join, what happens is in this program, t1 will start and then it will wait. T2 will not start until T1 is completed. Same thing goes to the main program. Main program also will not start. I mean, program completed will also not run until T1 is completed. So let's see. If I run this program, now see F1, F1, F1. Now F2 and program completed. Again F2 and F2. So at least F1, see T2 and main program is waiting until T1 is completed. That's why you see this F1, 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 and then F2. But F2, that's T2 and main program, there is no sync, it is happening simultaneously. Okay. So let's say we don't want that. We want this program completed to print after T2 is completed. So I will give T2 dot join. Now what will happen? T1 will start and then T2 will wait until T1 is completed and then T2 will start. And the main program will, this program completed line will wait until T2 is completed. See, run this. See, F1, 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 F2, 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 and then it will print program completed. That is a use of this join method. Okay, let's say I want T1 and T2 to run simultaneously, but then program completed should wait. It's like this. Okay, that means T1 and T2 start, T1 start, T2 start, but then it should wait for both to complete to move forward. That means this program completed line should be printed after both T1 T2 are completed. In that scenario, I will start both the threads and then give T2 T1 dot join, T2 dot join, and then give program completed. Okay. So now you see F1, F2 both will happen in parallel. See F1 printed, F2, F1, F2, okay, F2, and then it will finally print program completed. Right. So that is a use of this join method. Okay. So that's about the threading and multi-threading. In some cases, what happens is uh, when we do threading, sometime a race condition takes place. Now, race condition means two variables are, I mean, two threads are trying to access same variable. That is, let's say I have here a variable on balance. And here I have a method, let's say deposit. Okay. And I'm calling this three times, and then I'm incrementing the value of deposit. Balance. Balance will increase by one. If I'm calling deposit, so excuse me. So let's say we have uh, multiple threads. There are two threads here, right? Both the threads are calling deposit function, and they are incrementing the value of balance. Right, that means thread one will call it, and it will loop through three times. So three time deposit function will take care. So then account balance will be three, and then thread two also will be calling. So this will also update three times. That means finally the account balance should be six. Right, total we have deposited. For example, let's say $1 six times. So account balance should be six. Right. Uh, So let's say account balance. If I want to access here, I have to make it global. So I make global ACC balance. And then I give T1 start, T2 start, and then program. And finally, what I do, I want to print the value of account balance. Right. So I give balance is, and I give ACC balance. So let's run this. Problem account balance, we are making a deposit, right? So two threads we have created, both the threads are making deposit, and deposit function whenever they call it is incrementing the $1. Okay, so I run this. So you see balance is 6, it is showing, because in total we ran this two times we called deposit function, and each time it has incremented three times. Okay, $3 each. So that's why we got six. Okay, and what happens, let's say if I increase this to, let's say, 1000, that means 1000 times it will increment each deposit. So if I run this, it should actually show the total account balance should be what. So first time we are calling deposit function, it will increment 1000 times, means $1000 will be deposited. Thread 2 will also deposit $1000. So both the threads will deposit $1000 each, and finally we should get, you know, $2000, right? Because we have done this activity twice, so the $2000 I'm getting as the balance. Now, sometimes what happens if this number is huge, the number is huge, let's say, because these two threads are trying to update the same variable. Okay, so there could be a scenario, okay, where this particular variable will be, in a log state. That means the first function is calling it, it will be in a log state. Because it is a log state, the other function will, or other thread will not be able to update. So in that scenario we will not be having the correct value. Okay, the balance will not be correct, it will differ, because of the lock condition. This is also called as race condition. Okay, now in order to fix this issue, we'll have to create a lock. Okay, we have to create a lock, and so that this variable does not update. Okay, this variable does not come into a lock condition and we get the exact amount. Let's say I have deposited like what $10,000 each time. Totally, it should be $20,000. If there is a lock condition, this the amount will vary. The amount will be less. Okay, so to prevent that situation, we perform, uh, that is called as thread synchronization, where we want to synchronize the thread so that it doesn't overlap. All right. Now, for that, we need to create uh, a lock and perform the activity. But before that, since so this is a scenario where the lock exists. Okay. Now in Python, this scenario does not exist. Okay, I give this example to make you understand that what is thread synchronization. Like in this scenario, I have told you that there could be a situation where this variable will be in a lock state and other thread will not be able to update it, and finally we will not get the exact amount. These are to explain you thread synchronization. But in Python, this scenario will never exist because Python has an inbuilt uh, lock system wherein it will never ever allow multiple threads to update a particular resource. So we will always get the correct amount. Okay, so we don't have to worry about thread synchronization in Python. Otherwise, if this facility, if it was not there, then we have to do a lot of additional activities, like we have to lock this variable and then release that variable and make other threads to wait for it. So all that things is not needed. All right. So that's pretty much on threading, and use this concept to create more threads, more examples for a better understanding. All right. Thank you.